problems on queuing model 6 MMC FCFS infinity, which is multi-channel queuing model by using important formulae.
Let us understand some important formulas related to model 6, which is represented by MMC FCFS infinity. In this model, Poisson arrival distribution, Poisson service time distribution, this is multi-channel system, service provided on first come first served basis, number of customers arriving in system is infinity, and calling source or population is also infinity. This model is known as multi-channel queuing model. Let us understand some important characteristics related to this model. Several service stations are provided in parallel. So because this model is multi-channel model, so number of service stations provided should always be greater than 1, and these service stations provided in parallel. And it is also important to note that the service provided is same by each service station. Each customer is waiting in line can be served by more than one station. So because the service provided is same, so each customer can be served by any station from the parallel service stations. New arrival select station without any external pressure. So here it is up to the customer that he has to select any service station, because the service provided by each service station is same. Now let us consider one example, that is for train there are the tickets are provided. Now for this purpose there are number of service stations are serving in parallel, and it is up to the customer that he has to select any station to take the or to purchase the ticket. We will refer here N, that is the number of customers in the system, then C, number of parallel service channels, and we know that C should be greater than 1. Now we will move to the important formula. First, probability of empty system, that is P0 is equal to 1 divided by summation of n is equal to 0 to c minus 1 lambda by mu raised to n by n factorial plus lambda by mu raised to c by c factorial into c mu divided by c mu minus lambda. Now suppose the number of service channels provided is equal to 4. So if we take the values of c is equal to 4, then for summation we have to take the value of n is from 0 to c minus 1, that is 0, 1, 2 and 3, and then we can calculate the answer. Now we will move to the next formula, probability that customer has to wait. So when this condition will be getting satisfied, that is the number of customers in system should be greater than or equal to number of service channels provided. Now suppose there are service stations, C value of C is equal to 3, then what will happen if number of customers n is equal to 4, 5, 6, 7, then only this condition is getting satisfied, that is the customer arriving in the system has to wait. So how to calculate that probability? So P in bracket n should be greater than or equal to c, which is equal to mu into lambda by mu raised to c divided by c minus 1 factorial c mu minus lambda into P0. So for this probability, calculation of P0 is required, and we have to calculate by using this formula. Now next, probability that customers enters the service without waiting. So we have to take here the 1 minus probability of n should be greater than or equal to c. So simply we have to put here 1 minus and this whole formula. So 1 minus mu lambda by mu raised to c divided by c minus 1 factorial into c mu minus lambda into P0. Now we will move to the next formula, probability for idle servers. So in system, idle servers are there only when value of n is less than c. So probability of n less than c is equal to 1 divided by n factorial into lambda by mu raised to n into p0. Next, average number of idle servers. So average number of idle servers, that means servers are not in working, that means there are no customers for some servers, that is equal to C minus average number of customers served. Next, expected number of customers in the system. So here number of customers in the system, that means we have to calculate the length of the system, that is equal to lambda mu into lambda by mu raised to c divided by c minus 1 factorial c mu minus lambda square p0 plus lambda by mu. Then length of the queue, that is LQ is equal to LS minus C into lambda by C mu. So here CC is getting cancelled, so we can use the formula LS minus lambda by mu. So we can also use formula lambda mu into lambda by mu raised to C divided by C minus 1 factorial C mu minus lambda square into P0. Now if we compare these two formulas, then the formula, that is the first part, is same. Only difference is that this plus lambda by mu is not there. So here there is slight difference in the for the formula of the LS and L. For this multi-channel model, ratio of lambda by C mu should always less than 1. So this is in order to ensure Q does not explode. Then waiting time in system, Ws is equal to Ls by lambda. So for the formula of Ls, we have to just divide by lambda. Then waiting time in Q, Wq is equal to Lq by lambda.
First question. A tax consulting firm has 3 counters in its office to receive people who have problems concerning their income, wealth and sales taxes. On the average, 48 persons arrive in an 8-hour day. Each tax advisor spends 15 minutes on an average on an arrival. If the arrivals are poissonly distributed and service times are according to exponential distribution, find first the average number of customers in the system. Second, average number of customers waiting to be served. Third, average time a customer spends in the system. Fourth, average waiting time for customer. Fifth, the number of hours each week a tax advisor spends performing his job. 7. The probability that the customer has to wait before he gets service. 8. Expected number of idle tax advisors at any specified time. This question was asked Jammu University BE Mechanical 2004.
Let us understand the given data. Number of counters are given and that is equal to 3. So we can say that C is equal to 3. It is given that 48 persons arrive in 8 hours. So we have to calculate the arrival rate, that is how many number of persons arrive in 1 hour, and that is equal to, that is lambda is equal to 48 by 8, which is equal to 6 per hour. Now service rate is given, so service time is given, that is 15 minutes. So how to calculate service rate? That is 1 divided by service time, that is mu is equal to 1 divided by 15 per minutes. But now if we observe lambda is given in hours, so we have to convert this mu, that is also in hours. So we have to multiply this with 60. So 60 divided by 15, that is 4 per hour. So this is the service rate, that is mu. So here per minutes is given. Now we will find out what is the ratio lambda by mu. So lambda by mu is equal to 6 divided by 4. So we will simplify this, that is 3 divided by 2. So now this ratio, it is useful for solving the problems. So we have to calculate this. Now the first question is average number of customers in the system. So for the calculation of average number of customers in the system, that is length of the system, we have to first calculate probability of the empty system, that is P0. So how to calculate P0? So we have formula 1 divided by summation of n is equal to 0 to c minus 1 lambda by mu raised to n by n factorial plus lambda by mu raised to c by c factorial into c mu divided by c mu minus lambda. Now we will put the values. Now if we observe the first part of this, then here summation of n is equal to 0 to 2 and we have to take the value of n, that is 0, 1 and 2, and we have to put this value in this equation and we have to add. So now how we can write this? So suppose we will first take n is equal to 0. So 3 by 2 raised to 0, anything raised to 0, that is 1 and divided by 0. So I will write here 1 plus. Now we will put n is equal to 1. So when we put n is equal to 1, that is 3 by 2 raised to 1. So if we write here that divided by 1 factorial, that is plus 3 by 2 plus. Now we will put n is equal to 2. So n is equal to 2, that means 3 by 2 square divided by 2 factorial, that means 2 multiplied by 1. So 3 by 2 square, that is 3 square, that is 9, and 2 square, that is 4, and divided by 2. So we have to take 4 multiplied by 2, that is 8. So I will write here 9 by 8. I will complete the bracket. So this is the first part that we have completed. Now we will move to the second part. So for this second part we have to solve this. So 3 cube, that is 27 divided by 2 cube, that is 8, and 8 multiplied by 3 factorial, that is 3 multiplied by 2, that is 8 multiplied by 6, that is 48. Now we will solve this c mu, that is 3 into 4, that is 12 divided by 12 minus 6. So we have to solve this. So when we solve this, we will get the answer, that is equal to 0.21. Now we will put this value of P0 in this equation. So what is the formula for the LS? That is lambda mu into lambda by mu raised to c divided by c minus 1 factorial c mu minus lambda square P0 plus lambda by mu. So we will put the value lambda into mu, that is 6 into 4. 3 by 2 raised to c, so value of c is 3, divided by c minus 1 factorial, that is 2 factorial, c mu minus lambda, so c into mu, that is 3 into 4. So I will directly write the value, that is 3 into 4, 12 minus lambda, lambda is 6 square, into P0, 0.21 plus lambda by mu, so lambda by mu, that is plus 3 by 2. Now we have to solve this. So 2 factorial, that means 2 into 1. So when we solve this, so here we have to take 12 minus 6, that is 6 square, 36. So when we solve this, then we will get the answer 1.74. Now we will move to the second question. Average number of customers waiting to be served, that is the customers waiting in line. That means we have to calculate length of the queue. LQ is equal to LS minus lambda by mu. LS, that is 1.74 minus lambda by mu, that is 3.3 by 2, which is equal to 0.24. Next question, average time customer spends in system. So customer spends in system, that means WS we have to calculate, and which is equal to LS by lambda, that is 1.74 by 6, which is equal to 0.29. But here lambda is given for hour, that is unit is hour, so answer is also in hour, and we will convert it into minute by multiplying with 60, that is 17.4 minutes. Then average waiting time for a customer. So waiting time, that means customer is waiting in queue, that means we have to calculate the time spent in queue, that is WQ is equal to LQ by lambda, that is 0.24 by 6, which is equal to 0.04 hour, and we will convert this into minute by multiplying with 60, that is 2.4 minute. in next question we have to find out the how many number of hours advisor works in a week. So in 1 week we will consider 5 working days, and in 1 day there are total number of working hours, that is equal to 8 working hours. Now we will first calculate the utilization factor. So utilization factor, that means it will indicate the utility of the advisor. So utilization factor is equal to lambda by C mu. So which is equal to 6 divided by 3 into 4. So if we simplify this, we will get the 0.5. So out of total 8 working hours, 0.5 times, that is half times the advisor is working. That means we can say that in 1 day total number of hours advisor is working, that is equal to 4. So this is advisor works 4 hours per day. So in 1 week there are 5 working days. So advisor works 4 into 5, that is 20 hours per week. Now we will move to the next question, probability that customer has to wait. So when this is possible, so when the number of customers are greater than or equal to number of the counters, that is we can say that probability that customer has to wait, this is only possible n is greater than or equal to c. So for this we have to find out probability, and we have formula mu into lambda by mu raised to c divided by c minus 1 factorial c mu minus lambda. So we will put the values, that is 4, 3 by 2 raised to 3, c minus 1, that is 2 factorial, c mu, that is 3 into 4 minus 6 into p0. So here we have to multiply with p0, that is into 0.21, which is equal to 0.236. Next question, expected number of idle tax advisors at any time. Tax advisors are idle only when n is less than c, that is the number of customers in system is less than the number of counters. So we have to consider the value of n, that is less than 3, because c value is given, number of counters are 3. So we have to take the value of n is equal to 0, 1 and 2. Now when n is equal to 0, that is the number of customers in the system is 0, that means there are total 3 advisors are idle. When n is equal to 1, then number of customers is equal to 1, then there are 2 advisors are idle. When n is equal to 2, that means there is 1 idle advisor. So we have to find out the probability when the number of customers is 0. Then we have to also find the probability when n is equal to 1. But we have to put the condition, that is n is less than c. So how to find out the probability when n is equal to 1, that is p1, and how to find out the probability when n is equal to 2, that is p2. So these p1 and p2 with condition n less than c. So we have to apply the formula for n less than c. Now p0 we have already calculated, and we have to take that value. So p0 is equal to 0.21. Now when p, probability of n less than c, formula is 1 by n factorial lambda by mu raised to n p0. So we will put the value. So we will first find out p1 with n is equal to 1. So when we put n is equal to 1, then 1 by 1, 3 by 2 raised to 1 into 0.21, which is equal to 0.315. P2, that is n is equal to 2, 1 by 2 factorial, 3 by 2 square, 0.21, which is equal to 0.236. Now expected number of idle advisors. So this is the probability of the number of customers is equal to 0. So when P0 is 0.21, then 3 idle advisors are there. So we have to calculate expected number. So for that we have to multiply here P0. So when P0 is there, then 3 advisors are idle. So P0 into 3 plus when P1 is 0.315, then 2 advisors are idle. So P1 into 2 plus. So when P2 is 0.236, then one advisor is idle, that is P2 into 1. So we have to put the values. So here is I have written 3P0 plus 2P1 plus P2. So when we put the values, then we will get the answer 1.5.